Hello students, good evening. I am your chemistry mentor Harshit Agnihotri. So without wasting any time, I am bringing you the solutions of the test which I have taken in the coaching as well as in the school. So be ready, take out your pens and pencils out and let us go ahead with the paper itself. Okay. So answer the following questions. First is, what are radicals? Chemistry. What are radicals? Differentiate between acid and basic radicals. So radicals are group of atoms, group of atoms, group of atoms, or a single atom, or a single atom which which behave which behave as a which behave as a single single unit carrying 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 positive or negative charge. Now, a group of atoms which behave as a single unit carrying positive और negative charge को क्या बोलते हैं? इसको बोलते हैं complex या compound radicals. और single atom को बोलते थे simple radical. हमने बताया था radicals are divided in two parts, compound radical and simple radicals. So let us give some examples as well. Take some examples. For example, first calcium 2 plus and Na plus. So these are simple radicals. Complex radicals, hydronium ion H3O plus, NH4 plus, ammonium ion, and for these are basic radicals. And acid radicals are chromate, Cr, Cr2 dichromate ion, Cr2O7 2 minus. Okay, chromate ion CrO4 2 minus, permanganate ion MnO4 minus 1. So these are all what? Acidic radicals. Acidic radicals. Okay. This is a chromate ion. This is dichromate. This is chromate. Chromate. Are you all getting this? Okay. So next is what are radicals? Okay. Differentiate between acid and basic radicals. So here is the formula. A group of atoms, acid and basic radical, group of atoms which carry a positive charge, group of atoms which carry a negative charge are known as acid radicals. Example you can write this differentiation in the differentiation form. Left basic radical, right acidic radical, and that's it. Okay, why does phosphorus forms PCl5 but nitrogen does not forms NCl5? Explain. So question number 2, why does phosphorus forms PCl5? I have already told you phosphorus PCl5. So PCl5 is a phosphorus and nitrogen NCl5. Let us first check this information. Phosphorus and nitrogen, the atomic number of phosphorus is 15, so electronically configured 285, and nitrogen atomic number is 7, configuration 2 and 5. Both are having 5 electrons in the outermost shell, so both belong to the same group. Why? Because I already told you that group number is equal to number of valence electrons. How many valence electrons? 5. Number of valence electrons plus 10. So both belong to the 15th group. Both belong to 15th group, but one is forming a compound PCl5. This is the correct compound, but this compound cannot be formed. So this is the basic question. What? Phosphorus and nitrogen belonging to the same group, that is the 15th group. One forms PCl5 and another does not forms NCl5. So what is the answer? Phosphorus lies in the third period. Why? 1, 2 and 3. 3 shells. So phosphorus is an element of third period. Whereas if I talk about nitrogen is a element of second period. And we know that Bohr's atomic model states that the maximum number of electrons an atom can accommodate is 2n square. So if I put here 3, 2 into 3 square is equal to 3 3s are 9, 9 2s are 18. And whereas if I talk about this second period, so 2n square is equal to 2 into 2 square is equal to 4 into 2, 8. So that is where here we can clearly see that phosphorus can accommodate 18 electrons in the third shell, whereas nitrogen cannot accommodate more than 8 electrons in its second shell. The maximum electrons it can accommodate is 8 electrons. So let us see what is the basic difference here. Phosphorus, I'm rubbing this part. If you have noted, please stop for a bit and note this above part, the first question. Okay. So look here. I think you all till now have got a complete idea that why phosphorus is a third period element, because it has three shells, and nitrogen is having two shells because 2 and 5, these two shells. So being a member of a second period, it can only accommodate 8 electrons, and being a member of a third period, it can accommodate 18 electrons. That means phosphorus can expand its octet. Phosphorus can expand its octet. Okay. So now phosphorus makes PCl5. Phosphorus makes PCl5. It makes 5 covalent bonds like this. 5 covalent bonds like this. So how many electrons it is having right now? One. Each bond contains 2 electrons. So 5 bonds into 2 electrons. Total of 10 electrons. And this is stable as well, because the maximum number of electrons it can accommodate is 18. Here octet rule will not apply because phosphorus is of third period element. Now let's check for NCl5. Let us make this similar diagram. NCl, single bond Cl, Cl and Cl. How many bonds it has made? It has made 5 bonds, and each bond is having a 2 electrons. So 5 into 2 electrons, this is 10. This is not possible because nitrogen is a second period element. Second period element. Therefore, it can only accommodate a maximum of 8 electrons. Here it is coming 10. That is why this structure is not possible. Okay, so next question is this NCl3 possible? Is this NCl3 possible? Yes, of course it is possible, because if I tell you N single bond Cl, single bond Cl, single bond Cl, it is having a lone pair. Let's check how many electron nitrogen is having. So 3 bonds, that is equal to 3 into 2. 3 into 2 plus 1 lone pair plus 2 electrons. So 6 plus 2, 8 electrons. Is it clear? So this is a stable structure. NCl3 is possible, but NCl5 is not possible. I am assuming that you have now got this concept. If there is any doubt, please put up a question in the comment section. Is it clear? Okay. Just note this down and we are moving ahead. And in your book, there is also a statement written there. We have already discussed that nitrogen is showing a variable valency of 3 and 5. Nitrogen can only show valency of 3, covalency of 3, not 5. Because as soon as it will show covalency of 5, how many electrons would be there in the outermost shell? Right now I told you 10 electrons. So that is not possible with nitrogen. Okay. Explain the concept of variable valency. Also give 2 examples. What is variable valency? Variable valency. So variable valency, everybody knows this. Those elements which can lose electrons, the elements which can lose electrons from valence shell, plus penultimate shell, penultimate shell are said to exhibit variable valency. Lose electrons from valence shell plus penultimate shell. For example, let us take copper. We will not go to the electronic configuration because that is a part of class 11. So copper plus 1 and here plus 2. Iron plus 1 and here it is plus 2. Copper, iron, okay, and silver, Ag plus 1 and plus 2. Everybody knows this fact: copper, cuprous, cupric. Smaller valency is represented by us. Ferrous, ferric. Argentus, argentic. Okay. There are some of the more elements, but write a few examples. And we know that non-metals, phosphorus shows a covalency of 3 and 5. I have already made you write in the books. Nitrogen shows a valency of nitrogen only shows a valency of 3. And if I talk about chlorine shows a valency of 1, 3, 5, 7. Whereas sulfur shows a covalency of 2, 4 and 6. Just write all these things in your notes, those who have not written. Okay? What is covalency? Covalency is actually equal to the number of covalent bonds formed by an atom of an element. Just now we have, in the previous section we saw that phosphorus makes 5 single covalent bonds. 5 single covalent bonds with chlorine, and the product was PCl5, isn't it? The product was PCl5. So you can clearly see that it is making a 5 bonds, and each bond is having 2 electrons, so total of 10 electrons. Okay. 5 electrons, 5 is the covalency. Just count the number of bonds, it determines the covalency of that atom. Okay, so moving ahead, give any 2 examples. We have, I have give multiple examples, you can note. So the next part is explain neutralization reaction by giving an example. Explain neutralization reaction by giving an example. So neutralization reaction is what? Neutralization reaction. Very easy, very easy. Neutralization reaction: an acid reacts with a base. An acid reacts with a base to form salt and water. An acid reacts with a base to form salt and water. What is an acid? An acid is H2SO4 plus. Base, let us take caustic soda, NaOH. Okay. The result would be, this will dissociate into Na plus and hydroxide ion. This will dissociate into H plus and SO4 2 minus. What is the result? H plus OH. So the result is H2O plus. Na will be attracted towards the sulfate. So Na2SO4. So acid plus base is salt plus water. So this is an you can explain this and give an example like this. Is it clear? Define empirical formula. What is empirical formula? Neutralization reactions was D part. Now we are coming to E part. Empirical formula. Simplest empirical formula. Simplest ratio in whole numbers. Simplest ratio in whole numbers of different atoms present in one molecule of the compound. What is written here? Let us read again. Simplest ratio in whole numbers of different atoms present in one molecule of the compound. So let us take a few examples. Have you all written this? Just be quick, or you can pause in between and you can write the concepts. Okay, I'm rubbing this part. Okay, so here it is written one molecule of the compound. Let us take glucose for example. Glucose. What is glucose? Glucose is C6H12O6. Which is the highest common factor here? This is 6. Everybody knows highest common factor 6. 1, 6 2s are 12, 6 1s are 6. So what is the empirical formula? Empirical formula is simply C1H2O1. Or you can also write like this: C is to H is to O. You can write in the ratio format: 1 is to 2 is to 1. Both are two correct things. You will get the answer for both of them. And there is a question. It is saying hexanoic acid C5H11COOH. Hexanoic acid and acetic acid. Acetic acid is what? CH3COOH. Now, when the formulas are given, what you need to do is you need to write into the condensed form. So let us write this. How many carbon atoms are here? 5 plus 1, 6. So C6. Hydrogen 11 plus 1, 12. Hydrogen is 12. Oxygen is 2. So C6H12O2. Similarly, C2H4O2. Now, you can clearly see that both of them are having a common factor of 2. Cut it. 2 1s are 2. 2 6 are 12. 2 3. So its empirical formula comes out to be C3H6O1. And the empirical formula here is divided by 2. 2 1 2 2 2 1. C1H2O1. As simple as that, and you will get 1 mark out of it. it was 1 mark. No, it is of 2 marks. So the definition and the result. So this is also known as hexanoic acid. We will be studying this part in organic. All these are known as organic acids. Let me tell you, by the way, any compound having COH compound is known as a carboxylic acid, and because it is having carbon, so this is a organic acid. There are two types of acid: organic acids and mineral acids. What are mineral acids? Which do not contain carbon in them, like HCl, H2SO4. All these are known as mineral acids. Okay. And there is one exception for this case, like carbonic acid. That is an exception, H2CO3. Only exception which is having carbon, but it is coming under the heading of inorganic acid. Okay. Okay. Question number F. Question number F. You have to stop and write. Because if I give you time in the video itself, it will become too long. The next part is define empirically. We have done name a noble gas and a noble metal which shows covalency. So we have already studied that there are some reactivity series. What is that? K na ka mag al. Kinaka magal zaf. Kinaka magal zaf. Pub H. I'm writing here Cu Hg Ag AuPT. Now in this we can clearly see okay, what does this reactivity series represents? It represents that as you go down the group, the reactivity of metals decreases. So as you are going down the group, the reactivity of metal is getting decreased. So we can say that potassium is the most reactive metal, and Au and platinum are the least reactive metals. And we also know what are noble gases. Noble gases are the gases which do not react with anybody because they are stable. So that is why they are noble gases. Although these two elements or metals are not stable, but they also do not react. They also do not react with any other element. So that is why they are known as noble metals. And the reason is noble metals. And the reason is everybody knows because of the least reactivity. Least reactivity. So that is why they are known as noble metals. And if we talk about the variable valency, we very well know that gold shows a valency of +1 Aurus and a valency of +3. Platinum shows a valency of platinus and platinic. Platinus +2, platinic +3. Okay, you know these two elements are only soluble in a compound known as aqua regia. Aqua regia is also the king of acids. So these are only only soluble in that. Are you getting it or not? So these are known as noble metals. Next is a noble gas. So you need to learn this. Noble gas is xenon. Xenon forms a compound such as HCOF4, HCOF2. You will study all these compounds in detail in class 11, but for the time being, just remember that xenon forms some of the compounds. Okay? So these are the two compounds. So the noble question is over. Write the formula of the following compounds. Now we are coming part to the write the formula of the following compound. Okay, I am going to rub this part. Please stop in between and write down yourself. Do not leave anything. Sodium metaaluminate. Sodium. I am directly writing the formula. Sodium metaaluminate. Na plus 1 AlO2. AlO2 minus 1. So this is sodium metaaluminate NaAlO2. Next, aluminium phosphate. Aluminium +3, phosphate PO4 3 minus. So the result is AlPO4. This 3 and 3 will get cancelled. Why? Because they are having the same common factor, that is 3. So AlPO4. Third, ammonium zincate. Ammonium is NH4 and zincate is ZnO2 2 minus. So the formula becomes NH4 whole twice ZnO2. Okay. Fourth, sodium peroxide. Sodium Na plus peroxide O2 2 minus. The result is crisscross. The valency will get crisscrossed and the product would be Na2O2. Am I clear with this fact? Next, potassium oxalate. Potassium oxalate. So potassium is K plus 1 and oxalate is COO. This is an organic acid radical. Why? Because it is having carbon in it and it comes from an acid which is oxalic acid. So oxalate is COO2 whole twice 2 minus. So the product form would be K2COO whole twice. Now be aware that this 2 is not coming from the crisscross method, but it is the subscript of the formula itself. So do not cut this 2 and 2. It will become wrong. So this is the formula. That is why it is having a charge of 1. It will multiply it here and you will get only 2. Am I clear with this fact? Okay. Fifth, we have done calcium acetate. Calcium acetate. Okay, you have to remember that when acetate comes, acetate is first written CH3COO minus. This is known as acetate. Acetate. And calcium Ca2 plus. Calcium is Ca2 plus. Valency will get crisscrossed. The product form would be CH3COO whole twice Ca. This is calcium acetate. Seventh, aluminium carbide. Aluminium carbide. Aluminium shows a valency of +3. Carbon shows a valency of -4 in carbide. So what is the formula? Al4C3. This is aluminium carbide. Calcium dichromate. 4, 8, and this is the 8th one. Calcium dichromate. Calcium Ca2 plus. Dichromate Cr2O72 minus. Cr2O72 minus. This gets cancelled. Formula is CaCr2O7. Ninth, potassium ferrocyanide. Potassium ferrocyanide. Potassium K plus 1 and ferrocyanide is FeCN6 bracket 4 minus. Valency will get crisscrossed. K4 FeCN whole 6. K4 FeCN6. Potassium ferrocyanide. Sodium plumbite. 10th. Sodium plumbite. Na plus 1 PbO2 2 minus. Result is Na2PbO2, sodium plumbite. So these are some of the radicals which you need to learn. They are important. Okay, coming on to the next part. Done, everybody? Okay. Valency, X valency 3, X valency is 3 and Y valency is 2, X valency 3, Y valency 2. You don't need to consider whether these two are metals or non-metals because we have already done some of the questions in which the two are the non-metals. For example, if I give you the case, do not take this as metal and this as the non-metal. Why? If you will do the product will be same. But for example, if I ask you sulfur and oxygen, so sulfur there is a compound which is known as sulfur dioxide. Sulfur dioxide. In that case, remember that if you do the crisscross method, here it is nothing, so it is 1. So when 1 is here and 2 is here, 2 will come here, so it will become 2, and O will come here, it will become 1. Is this possible? No, because we know that oxygen cannot show a valency of 1. It can only show a covalency of 2. So multiply both the charges with 2. This becomes S4 and this becomes O2. So see here, I have not put any kind of charges in S and O here. Why? Because these elements are showing covalency. These elements are showing covalency. That is why I have not put the charges here. Similarly, you can do this here. X is having a charge of 3. Y is having a charge of 2. Let's crisscross this. So X2, Y3. This is the product form. And it's as easy as this. Okay, 4 oxy acids of chlorine and 2 of sulfur. Now we have already done, this is known as hypochlorous acid. Hypochlorous acid. Hypochlorous acid. Next, HClO2. These acids only differ in their number of oxygen atoms. Chlorous acid. Chlorous acid. Next is HClO3. Chloric acid. Chloric acid. Then HClO4, perchloric acid. Perchloric acid. So these are some of the acids. Okay, and everybody knows the two oxy acids. Now it is given that oxy acid. Now What is oxyacid? Oxyacid are those compounds which contain one element other than oxygen and hydrogen plus addition to hydrogen and oxygen. One other element in addition to hydrogen and oxygen are known as oxyacids. One other element addition to hydrogen and oxygen is known as oxyacid of sulfur, oxyacid of chlorine. Oxyacid of sulfur, this is sulfuric acid, and this is H2SO3. This is sulfurous acid. Sulfurous acid. This is sulfuric acid. Are you all getting this? Sulfuric acid. So you can basically see us means less number of oxygen, it means higher oxygen. Similarly, HNO3, oxyacid of nitrogen. This is nitric acid. Yashashvi, calling out to you. You don't remember this nitric acid. I'm so sorry. I have to call out your name. HNO3, nitric acid, and HNO2. This is nitrous acid. Nitrous acid. Okay, now learn, and I'll be giving you these sheets of the formula sheets which are important for class 9. So don't worry. But for the time being, you should remember what is this nitrous and nitric. There is one more acid. Just go home. You must be already at home. But I want you to search the acids of phosphorus, oxy acids of phosphorus, and tell me how many are there and what are their names. Just write down in your notebooks oxy acids of phosphorus. Okay. Ratio by mass in CO2. Ratio by mass in CO2. I was unable to understand why the students have done this wrong. It's so much easy. I think I haven't given the charge, that is why it is. So look here, carbon is 12 gram, oxygen is 16 gram. So let us find out the ratio. So carbon is to oxygen. There are two atoms of oxygen. See here, two atoms are written. So carbon, the mass of one atom is 12 gram, and the mass of two atoms would be 32 gram. 32 gram. This and this gets cancelled. 4 3s are 12, 8 4s are 32. So the result is 3 is to 8. This was it. 3 is to 8. Let us take a few more examples. One more example, example 2. You have to find out the ratio by mass of hydrogen. Hydrogen, mass of one atom is 1 gram, and oxygen atom is 16 grams. So what is the result? So hydrogen here, 2 atoms, 2 gram, one atom is 1, so 2 atoms, 2 gram, and oxygen would be 16 gram. So the ratio by mass of hydrogen and oxygen is 1 is to 8. So that is it. Now you find out in homework, you find out the ratio by mass of C2H6 and CH4. Example 4. K part. K part. What are free radicals? Give any two examples. What are free radicals? Give any two examples. Free radicals, I've already told, I'm not going into very detail. Free radicals are the species which are formed by the homolytic fission of a covalent bond. Homolytic fission of a covalent bond, such that the species so generated contains an unpaired electron. For example, just write this. If you have written this, that is perfectly all right. Homolytic fission of a covalent bond such that the species so generated contains an unpaired electron. For example, chlorine free radical Cl dot, or hydroxide free radical OH dot, nitrate free radicals. And what is oxidative stress? Today there were many students who did not know what was oxidative stress. So let me tell you, oxidative stress is it's a state. Whenever there is a state produced in the body whenever there are more free radicals than the antioxidants. This creates an imbalance. Oxidative stress is that state where quantity of free radicals in the body gets increased as compared to antioxidants. So this creates a stress in the body, and that is known as oxidative stress. Oxidative stress. And oxidative stress leads to early aging. Early aging, whitening hair, whitening of hair, etc. Whitening of hair, etc. Are you all getting this? Okay. So this was calculate the percent define oxidant, give an example of antioxidants. What are antioxidants which can eliminate the free radicals in the body? I've already told you vitamin C and vitamin E. Vitamin C and vitamin E are the two vitamins which can stop the generation of free radicals in the body. Calculate the percentage composition of carbon present in a sample of wine containing 30% ethanol. Let the sample of wine, let the sample of wine be 100 grams. Let the sample of wine be 100 grams. So 100 grams, sample of wine is 100 grams. So what is the percentage of ethanol or the mass of ethanol present in that? Because it is containing 30%, so 30 upon 100 into 100. So basically this will come out to be 30 gram. So 30 gram of ethanol is present in that sample. And if I talk about, let me give you that carbon is having an atomic mass of 12 gram, hydrogen is having an atomic mass of 1 gram, oxygen is having an atomic mass of 16 grams. So what is C2H5OH? This is ethanol. This is ethanol ethyl alcohol. Let us calculate the gram molar mass. 2 into 12 plus 6 plus 16. 24, 30. 30 plus 16 comes out to be 46 grams. So 46 grams, students, you can clearly see that carbon is 2. So and the atomic mass of carbon is 12. So basically, what is the total mass of carbon present? So we can say 46 grams of ethanol is carrying 24 grams of carbon. I hope this is clear. This is 2 atoms. So one atom mass is 12. So 2 into 12, 24. 46 grams of carbon is having 46 gram of carbon is having 46 grams of ethanol. Ethanol is having 24 grams of carbon. Now, how much ethanol is present in the sample? 30 gram. So you do the unitary method. What is unitary method? You have to apply it here. 1 gram of ethanol. 1 gram of ethanol, C2H5OH, will be carrying how much carbon? So in order to make this 46 one, you will divide this number by 46. So you have to divide RHS also by 46. So 24 upon 46. Let me tell you this fact. This